In this video, we're going to look at a piecewise defined function. What is a piecewise defined function? A piecewise defined function is a function that uses different equations depending on where you are in the domain of your function. For example, we have a telephone company that's offering the following plans. If you use 60 minutes or less, they're going to charge you a flat rate of $20. So $20 buys you 60 minutes. Each additional minute that you use your phone is going to cost you 40 cents per minute. So we can represent this example using mathematics. And we can represent this as a function. So if we use anywhere between 0 and 60 minutes on our telephone plan, we're going to get charged a flat rate of $20. But the minute we go over 60 minutes, then we're going to get charged using this equation. For example, let's say I use 61 minutes. So for that additional minute, I'm going to get charged 40 cents plus the flat rate of $20. So if I use 61 minutes, I'm going to get charged $20.40. Let's say I use 62 minutes. If I use 62 minutes, for that 2 minutes I was over 60 minutes, I'm going to get charged 40 cents a minute or 80 cents. So my total cost for using 62 minutes would be $20.80. This is a piecewise defined function because we're using two different equations to define our function depending on where we are in the domain. If we're between 0 and 60 minutes, we use the equation C of t equals 20. If we're greater than 60, then we use the equation C of t equals 20 plus 0.4 times t minus 60. The graph of this function looks like this. For the first 60 minutes, or from 0 to 60 in my domain, my function is a constant function. It's flat. So it doesn't matter if I use 0 minutes or 60 minutes, I'm going to get charged $20. As soon as I go over 60 minutes, then I'm going to use this equation to determine my cost. So again, if we're at 61 minutes, then we're going to get charged $20.40. So this equation is a line, a non-vertical, non-horizontal line. So that is going to be the graph of our second part of this piecewise defined function. So how do we evaluate a piecewise defined function? To evaluate a function at a particular value of our input, we just make a substitution. But now we're going to have to determine where is my input located, in which interval over the domain is my input located. So I'll know which equation I need to use to find the value of that function at that input. For example, C of 40. How do I determine what C of 40 is? Well, my input to my function is 40. So I need to decide which interval contains the number 40. Is 40 between 0 and 60? Is 40 greater than 60? Well, 40, of course, is between 0 and 60. So we're going to use the first equation, C of t equals 20, to evaluate this function at 40. We're going to use the first equation. So C of 40 is just equal to 20. So if I used 40 minutes, it's going to cost me $20. Okay? What about C of 80? Well, again, I need to determine where that input 80 is located. Is 80 between 0 and 60? No. Is 80 greater than 60? Yes. So I need to use this equation to determine my output given my input is 80. So C of 80, I need to use this equation to determine what that is. Okay, so C of 80 would be 20 plus 0.4 times 80 minus 60. All right, so let's calculate the math here. 80 minus 60 is 20. 0.4 times 20 would be 8. So this is going to cost us $28. So if I use 80 minutes of time on my phone plan, it's going to cost me $28. Okay, so a piecewise defined function is a function where we define the output using different equations depending on where our input is in our domain. Okay, we can also graph these. And to graph a piecewise defined function, you graph each piece separately. So I'm going to graph f of x equals 3. And I'm going to graph that for x is less than or equal to -1. And I'm going to graph f of x equals x minus 2. And I'm going to graph that for all my inputs greater than -1. Okay, so let's graph that first piece. Let's graph f of x equals 3. And I'm going to graph this by plotting points. And I'm going to plot 3 points. -1, -2, -3. So I need to pick 3 points that are in my interval x is less than or equal to -1. Now, this is a constant function. So it doesn't really matter what I pick for x. For every x, this function is a constant, and that constant is equal to 3. So at x equals -1, the value of the function is 3. At x equals -2, the value of the function is 3. At -3, the value of the function is 3. So I'm going to get 3 ordered pairs, -1, 3, -2, 3, and -3, 3. And I'm going to plot those ordered pairs on my coordinate plane. All right, now let's look at the second piece, the second part of this function. We're going to evaluate f of x equals x minus 2. Now I need to evaluate this for values of my input x greater than -1. However, I am going to plot the point x equals -1, and I'll show you why here in a second. So I'm going to pick 3 points starting at -1. I'm going to go to 0, and I'm going to go to 1. Again, -1 is not contained in the interval x is greater than -1. But I need to plot that point to know what the graph looks like at that point. Okay, so let's evaluate this function at -1. -1, it's -1 minus 2, that's -3. So we get the point -1, -3. At 0, we're 0 minus 2, which is -2. So we're 0, -2 is the point we're going to plot. And at 1, 1 minus 2 is -1. So we're going to plot 1, -1. So here are the 6 points that we're going to plot on our coordinate plane. All right. Sorry about that. Okay, so here's our coordinate plane. Let's plot those points. So at -1, the value of our function was 3. So -1, 3. And that is going to be a solid dot. And it's a solid dot because we have equality. And when we have equality, we include that point in the graph of our function. So since we have equality, we're going to graph that as a solid dot. Okay, and we also had what? -2, 3 and -3, 3. So this part of the graph of my function is a horizontal line. It's a constant function. Okay, now let's graph the second part of this piecewise defined function. Now remember, We evaluated this function at -1, even though -1 is not included in the interval for the second part of this piecewise defined function. And we found at -1 the value for our function was -3. So at -1, -3, I'm going to plot this as an open circle. Why an open circle? Since we don't have equality, we're going to use an open circle to represent that point. An open dot. Okay, and now we can plot the other 2 points. We had 0, -2, and 1, -1, and then we can graph this by connecting the dots. So the second piece of this function looks like that line. Again, why do we have an open circle at -1, -3? Because -1 is not included in that piece of the function, so we graph it with an open dot.